So last class we discussed about abstraction. So showing the essential things and hiding the unnecessary details from the user. So I also discussed about the final keyword, and we are about to discuss a static keyword in this session, then followed by interfaces and their properties. So let me open a folder. Fine. Let me open a Paint application. So now I am explaining about the static keyword. So the static keyword we have been using with the main method, public static void main. And if you remember, I told about the static keyword that if a member is having a static keyword, that is, the member is qualified with a static keyword, then that member belongs to class. And if a member does not have static keyword, that is, if a member does not qualify with a static keyword, then that member belongs to object. So we know that in Java, objects can be constructed using classes. So what some members belongs to class and what members belongs to object means. I'll give you an example here. So here, assume I have a dog class and I am having some properties like a size. Let me write here. So I am creating an object dog. The object equals to new dog. Okay. Then onto the dog object that I just mentioned size equals to 4. So what it means? Better say instead of dog object I say Hutch dog, and here Hutch dog. It means Hutch dog size is 4. So what happens in JVM is, so remote control, with the buttons in it. So size, height, those buttons, properties of dog. Then object, object. So here, when the statement hutchdog dot size equals to 4 is executed, what happens is it means on this remote control you are pressing the button size. It means you are setting size as 4. So internally what happens is here the hutchdog object gets size 4 here. You can see there is a small circle I mentioned, the size as 4. So here let me change size equals to 4. 4. And here it is hutchdog object. Hachdog object. So similarly, if I say for the same dog class, I am constructing Doberman dog object. I have one dog class and I am constructing two objects for that. One is Hachdog object, the other one is Doberman dog object. So for Doberman dog object, dot size equals to 8, I say. So it means same again, remote control. So for this remote control, I'll draw the mapping here. Okay, then another remote control for Doberman dog object, and of course buttons on it. Then actual Doberman dog object. So let me write here Doberman dog. Then if you see here size variable, so it has size variable here, and whose size equals to 8. So let me write here size equals to 8, and let me show mapping so that it is easy to follow. Yes, here goes. So in these two objects, the size variable, so let me write dog class here for your reference. Class dog, open close brace. Here goes its properties. So I mentioned here properties. In properties, one is int size. So similarly, there may be height, string name, and so on. There are properties. Also, there are methods here, and here goes variables. These are variables. So now the size, height properties in dog are not having any keyword static here. So we call them as non-static members. So let me write here non-static members. So with non-static members, what happens is, so let me give some space here. So with non-static members, what happens is, I'll write here non-static. Non-static members. Non-static members, every object has its own copy of memory area. This is the thing happens in JVM. Right here. So with non-static members, so if you observe here, size variable in my class dog, is a non-static member, and here there are two objects in the JVM, Hachdog object and Doberman dog object. So Hachdog object has size, Doberman dog object has size here. If you see over there, the size variable has its own value for HDOG object, that is 4, and Doberman dog object has the size its own value 8 for it. So it means every object has its own copy of memory area for size variable. It means this size variable has its own copy of memory here. Size variable has its own copy of memory. Of course, the value is different for a Hutchdog object and Doberman dog object. So that is what happens with the non-static members. Now, suppose with the static members. So what happens with static members is, in this class dog, I deliberately write one static member, I say string color. So here it should be static. So I qualify with keyword static, static color. So let me organize this code. So it will be something like this. Static string color. Right. So here, suppose if I say static color white, let me expand this, white. So here static color white. So it means, so if I want something that is common across all the dog objects, then I can qualify that with static. So it means something which is common. So here color equals to white. So it means this property would be common. So let me draw a line. So which is common to Doberman dog object and Hutchdog object. So let me write here this property. Yes, let me mark like this. So here it means white Hutchdog, white Doberman dog. It is something similar to global variables in C programming. So global variables has values which are common across all the functions in C programming. Similarly, if you want something common across all the objects, then that property can be marked as static. So where the copy of the memory for color static is same for Hutchdog object, Doberman dog object. In future, if you create maybe Alsatian dog, German Shepherd dog, street dog, and so on, if you create, then this color would be common across all those objects. So if you want something that is common across all the objects, then you can qualify it with static. So non-static members has, every object has its own copy of memory. So for size, its own copy. Size, its own copy for Doberman dog, then Alsatian dog, and so on dogs which you are creating in future. So let me write here static members where every object has the same memory area, And how do you access these static members? So let me write here, how do you access static members? that is the traditional way. So there are two ways, using the object and the dot operator. That is, example, in our example, dog object, HDog object dot color you can access. Second way is using the class name itself and dot operator. That is, you can directly use class name dog dot color. So this is how you can access. So here the second way is the recommended approach. So let me write here. So you can access the static members using the dot operator, that is the traditional way, creating the object and a dot operator and using the member. So the second way is directly using the class name dot member. So the second way is recommended because if you observe the hdog.color or dog.color, by seeing in the second, that is class name.color, we can come to a conclusion that this color member is static and it is referred or accessed using class name. Suppose if you see the first statement hdog.color, so over there the traditional way of accessing the members of the class. So over there hdog.color, by looking at that particular statement, we cannot confirm that a color is static or non-static member. But by looking at a second statement example, that is dog.color, it is clear that color member is static. So a blind hint is static members belong to class. Non-static members belong to object. This is a blind hint. So you need to remember this. Let me mark this blue in color. Okay. Save this. I'll save that in your folder. Yes. So static members in Java. Yes. Of course, I'll share this image with you to understand what static is. So static members belongs to class. It means that those can be referred as global variables. Non-static members can be referred as local variables that are for each object. Now I'm going back to interfaces discussion. Let me search where I left. Yeah. Oh, naming convention. Okay. Section interface. Yeah, here. So interfaces, they are similar to classes. They have variables and methods. So variables by default are public, static and final. So these are the default properties for variable. Whenever you are using interfaces, then if you are creating variable, they are by default public, static and final. Methods. So by default, the methods in interface are public and abstract. If you see over there, they are abstract. All the methods in interface are by default abstract. It means they don't have a method body. So their method bodies are implemented somewhere down the line. So here we use implements keyword to refer to these interfaces. So here, why these interfaces are actually introduced in Java? So previously in our example, animal, mammal, dog. So here, mammal is extending animal, dog is extending mammal. So suppose, for example, let me write here, I'll write here. So I say example class A extends B. So I did not say anything about class A extends C, D, E, F, so on. It means one class extending B, C, D, E, F, like these multiple classes. So I did not say anything about this. So it means one class A is having multiple parents. So here, this is really not possible with classes. So let me explain you with a picture so that it would be easy to you to understand. So let me go back. I have saved this. Let me open new paint. So assume I have classes. Classes. Let me label here. This is class A. And here goes B. Here goes C. So let me put here C. And here goes D. Look there. Assume all these are classes. So class A, B, C, D. And here A is parent, B and C are children of parent A. Then D, you can see here D is inheriting from B and C. So assume there is a structure like this. So A is the parent and B and C are children, and D is a child acquiring properties from B and C. So here these are classes, and we know that there is inheritance relationship, that is inheritance relationship between A, B, C. That is A being parent, B and C are being children. And D is also participating in inheritance, that is D is inheriting properties from B as well as C. Now assume there is a method in A, this method name is show. And by using Java's overriding mechanism, assume B, which is inheriting from A, has overridden show method. So here B and C, I'll write here. B and C has overridden show method. Of course, we can do right, because in children objects, children objects can override parents methods, and that is known as method overriding in Java. So here I assume B and C, both which are inheriting from A, can override show, and they have overridden show. Now B has a overridden version of show and C has an overridden version of show. So C's own version and B's own version, of course. So now D is inheriting from B and C. Now B has show, C has show. Now in this case, D, when it inherits, the show method from B and C, B and C, B and C, then which version of show method is being overridden? So let me write here and I'll highlight in red color. Yes. So what I'm doing is D is inheriting from B and C, and D is trying to override the show method that is present in B and C. In that case, D is overriding what version of show, that is B's version of show or C's version of show. So it is difficult to find out which show method is being overridden in D, and this is known as Deadly Diamonds problem, we say. So when D is having multiple parents B and C, we cannot determine D what version of parents show is being overridden here. So this is known as Deadly Diamond problem, and this problem is to be addressed. So to address this problem, they have introduced interfaces. So let me write here interfaces. So introduced to show multiple inheritance. This is the main purpose of introducing interfaces. That is multiple interfaces. So one class can have multiple parents. I mean, which I just wrote here, class A extending B, C, D, E, F, like this something. So this is known as multiple inheritance, we call it as. So when animal and mammal you are just discussing, it is single inheritance. So just animal and mammal if you are discussing, they are single inheritance. So I say types of inheritance here. So in types of inheritance, one is single inheritance. That is nothing but two classes participating. Mammal extends animal. It is single inheritance. Multi-level inheritance. It is having three levels. Dog extends mammal, mammal further extends animal. If you see in our examples, we have been using multi-level inheritance. So there are three levels over there. So grandparents, parents, children, three levels. So that is why we call it as multi-level inheritance. Similarly, we have multiple inheritance. So multiple inheritance, that is nothing but class A. So here in multiple inheritance, we don't use extends keyword. Instead, we use implements B, comma C, comma D, comma E, so on, where B, C, D, E are interfaces. They are interfaces. So one class can inherit from multiple interfaces to achieve multiple inheritance. So multiple inheritance can be seen in Java only through interfaces, because with the classes that would lead to deadly diamonds problem. So this is one of the important interview questions. So they may ask you what is the purpose of interfaces, and you should explain it with this deadly diamond problem. So interfaces. Close this. Oh. So I'm going to write an example using same hierarchy. So what I'll do is right click, test drive, multiple inheritance. Test drive, multiple inheritance demo. So I have a main method here. So here I am assuming animal as an interface. So here interface. So we start with keyword interface, then followed by the interface name. So interface animal. Interface animal. So here goes properties. So properties, variables, methods, methods. So here let me put methods here. Those eat, sleep, drink. So eat, sleep, run. So void eat. Observe that in interface I already told you all the methods are abstract. So the methods will not have method body in it. So without a method body I just terminated by semicolon. And they are by default public and abstract. Even though you qualify with a keyword public or not, still the methods are public and abstract. So similarly I write void sleep. Here whether you qualify it with the abstract keyword or not, still it is abstract. Then void run. Yes, still it is public and abstract. Here it is still abstract. Here it is still it is public, even you don't mention. So because by default the methods are public and abstract methods. So I defined an interface. Now with this interface I cannot do anything because there are no method bodies here. And second thing is interfaces, we cannot construct an object. So let me open the notepad. Here I have written the properties. We cannot create an object for interface because interfaces are not classes. We can construct only object to classes. So we cannot create an object for interface, but reference variable can be created. Of course, I'll show you by example. So here what I'll do is just having an interface with abstract methods, we cannot do anything. We need to have some components that would provide bodies for these methods. Those are nothing but classes. Class, mammal. So how I am establishing a relationship between this animal and mammal is by using keyword implements. Implements animal. So what I'll do is, I already have mammals with the same name. What I'll do is mammal 5 I say, animal 5 I say, animal 5. Yes. So here, look there, mammal 5 implements animal 5. So the thing is, another thing I would like to highlight with these interfaces, that is, interfaces are establishing a contract between the interface and the classes. So here, in this case, animal 5 and mammal 5. So what the contract is? Interfaces have abstract methods, and whoever the class is implementing it, then that class should provide a definition for all the methods present in the interface. All the methods I say. So mammal 5 has to provide definitions for all the methods. It means class mammal 5 is implementing animal 5, which means mammal 5 is promising interface animal 5 that, hey interface, I am implementing you and I promise that I am going to provide definition for all your methods present. So here mammal 5, if you see here, the type mammal 5 must implement the inherited abstract method eat. Of course, it will show for all the abstract methods eat, sleep, run also. So what I am doing is, I need to implement eat method definition. So what I am doing, system.out.println, I say mammal eats. Look there, I provided definition for eat, and when I provided definition here, there is another rule that to be observed. Cannot reduce the visibility of the inherited method from animal 5. So eat method is having an access specifier public, and in mammal 5 I just tried to implement the definition. I mentioned void eat. So here eat method does not have a qualifier access specifier. It means it is having default access specifier. And while discussing access specifiers, I already told you public is having no restriction, whereas default access specifier has some restriction, and default access specifier is package level restriction. So you cannot reduce that visibility. You need to maintain the same public. So now you don't have any error here. And still mammal 5 is highlighting with error, mentioning that you need to class mammal 5. You are promising with the animal 5, promising with animal 5 that you are going to provide definition for all the methods. So you have provided definition for eat, and you have to provide definition for sleep also, because sleep also is abstract. You can see here. Sleep also is abstract. So public void sleep. So system.out.println, Mammal sleeps. So let me correct the spelling, public. So here I have provided definition, that is Mammal 5, after promising the contract that it is going to provide definition for all the methods, Mammal 5 has provided definition for eat, sleep. Eat, sleep. So here, assume Mammal 5 is not interested to provide definition for run method, assume. In that case, Mammal 5 is breaking the contract, which means it is failing the contract. When it is failing the contract, Mammal 5 is inheriting an incomplete method, that is run, incomplete method. When class is having incomplete method, then that class becomes abstract, I already told you. So in that case, you need to qualify it with abstract keyword. That is why there was an error. Now you can see there is no error. So somewhere down the line, we need to implement that run method. So what I'll do is class dog can extends Mammal 5. So I name it as class dog 5. So it is extending Mammal 5, and here you can see dog 5 must implement the inherited abstract method run. So I can do this, add unimplemented method. And here the method stub for run is generated by Eclipse, and I can add here dog runs. Dog. So here dog is a concrete class, and mammal is an abstract class, of course. Abstract class, interface, of course, then. So I'm done. Here in my main method, try creating an object for interface. I actually told you we cannot create an object for interface. So try animal 5 it is. Let me name it as animal 5. Animal reference equals to new animal 5. Immediately JVM will throw an error. Cannot instantiate the type animal 5 because it's an interface. You cannot instantiate. You cannot create an object. So what I'll do is I'll copy this message for your reference here, indicating that we cannot create an object for interface. So what I'll do is I will break that into statements. This one, animal reference. Here, animal reference equals to, so polymorphism. So polymorphism. So with polymorphism, what? Superclass remote control, we can assign subclass object. So subclass object, that is new. I try assigning mammal object, mammal 5. Observe there, I tried assigning mammal 5. Mammal 5 object cannot be assigned to superclass remote control. The reason is mammal 5 is abstract. And we already discussed that abstract classes we cannot create object. So that is the reason we cannot instantiate mammal 5. So in that case, so I just mentioned the comment here for your understanding. So for this animal reference, we can go doc 5, of course, it's valid because doc 5 is concrete class. And by using this doc animal reference remote control, dot, you can say it, of course, animal reference dot eat, so it will get into eat method present in dog. Dog5 eat method physically not available. Then it will go for next parent, mammal 5. Eat method is available here and it is having a definition mammal eats. So when I execute this, of course, it displays this mammal eats. If you want, you can override that eat method in dog and override to dog specific eat method and it will display dog eats. So the things to be observed are interfaces have members, the variables are public static final, methods are by default public and abstract, and with interfaces you cannot do anything, we need to have classes. So those classes would be implementing the interfaces. So here interfaces are used to achieve multiple inheritance in Java, and interfaces will establish a contract between the parent and children. So the children should obey the contract. If they are not obeying, then those children, that is classes, becomes abstract. So those are the things with interface. And here let me add another thing. Interfaces are 100% abstract. I mean, when you say, I am comparing with the interface and abstract. With abstract class, we have seen abstract classes can have concrete methods as well as abstract methods. Whereas interfaces, all the methods are by default abstract. So with interfaces you can achieve 100% abstraction. Whereas with abstract classes you can achieve only partial abstraction. So this is another important point which you need to highlight when someone asks you the differences between abstract class and interfaces. This is one of the important interview questions which the interviewer will ask you to explain the differences between the abstraction and interfaces. So interfaces provide 100% abstraction, whereas abstract classes provide partial abstraction because they have concrete classes in it. And let me go back to the example which we referred to, that is passport scenario. So let me search. Yes. So here passport application, verification process, that is photo identity and residence. So Delhi is the headquarters and Hyderabad and Chennai are two sub branches. So Delhi being the interface, and of course here it has final approval method and verification method. Both are abstract, you can see here. In my previous example, final approval was concrete method and verification method was abstract, and that verification method was implemented by Hyderabad and Chennai branches. So here, in this case, interfaces will have all the methods as abstract. So approval and verification both are done by sub branches itself here. So verification in Hyderabad branch is done against the driving license of the applicant, and verification in Chennai can be done against the voter card of the applicant. So here no candidate is going to approach Delhi branch directly for passport. they have to approach through Hyderabad and Chennai branches only. In this case, the approval authority, final approval also is done by the branch itself. That is either Hyderabad branch or Chennai branch. Previously, the final approval process. So the documentations are carried forwarded to Delhi, and Delhi office, Delhi branch is having the authority to approve whether the candidate can be given passport or not, final approval. So that is the difference here. So with Delhi here interfaces, all the methods are abstract. And with the sub branches here, so both final approval as well as verification is done by the sub branches. So that's about interfaces. So interfaces purpose is to achieve multiple inheritance. For now, I am going to wind up my session, and we shall meet tomorrow the same time.
Okay.
Okay, thank you.
All right. I'll share this on my YouTube channel. You can download it.
Okay.
Okay, fine.
Thank
See you tomorrow.
Bye.
Okay, bye.